Okay, here we go. Writing linear equations. I love this section. It's a great section. So, we've learned, up until this point, we've learned 3 different templates for linear equations. One of the very first one in the first trimester was slope intercept form. That was the linear form, and slope intercept form was y equals mx plus b. And we initially learned how to graph it. So we learned how to graph the equation given an example of y equals 3x plus 4. We knew how to pull out the slope and the y-intercept, and then we were able to graph it. And we could graph that equation in that linear form. And then the second part of that was we reversed it. So let's do this actually. That's good. And then the next thing we did was we learned how to write it. So we were given a coordinate, we were given a graph, and we had to write an equation for that line. We were either given that type of information, we were also given the slope and the y-intercept, and then we had to take that information and write an equation in slope-intercept form. So that was the first thing that we did in our first semester. Our second semester now, what we learned was standard form. And standard form is ax plus by equals c. And earlier this month, we learned how to graph that. And we learned how to graph that because we were able to calculate what the x and the y-intercept. Today, we're going to work on learning how to write an equation in standard form. And then the other form that we had learned was point-slope form. And point-slope form was y minus y sub 1 equals m times the quantity x minus x sub 1. And we learned how to graph that. So we learned how to pull out the point and the slope from that equation. So you notice that in point-slope form, we were able to either plug in or pull out the slope or a point. In standard form, we couldn't pull out any slope, no intercept, etc. We could calculate what the x and y intercept, but none of these variables represented any of those values. Notice the variables represent the slope and the point. It does actually, we have a point. That is the one thing, but we can't pull it out because typically an example looks like 3x plus 4y equals 12. So x and y are left blank. In this example that we typically see, we see y minus 6 equals 3 times the quantity x minus 4. So we know that the slope is 3 and the slope equals 3 and the point equals 4, 6. So notice that those values represent something. In this standard form, those values don't really represent anything. A, B, and C don't really help us with graphing. And then in here we're given the slope. Oh, that's not what I want that. We're given the slope, which is m, and we're given the y-intercept. So that's something that's a little bit different that we don't see. Okay, so it's important that when we learn to write, we're going to use that information to write those equations. So the difficulty of this is that standard form, we really can't plug it into its native form. We're going to have to use either slope-intercept form or point-slope form to help us initially write an equation, and then we will manipulate that equation so it will be in standard form. One last thing that we want to talk about when writing in standard form, we need to remember these three components, these three criteria that need to stay true. That A must always be positive, needs to be a positive number. We need to remember that A, B, and C must be integers. And we need to remember, this one's an interesting one, that X and Y are on one side and that the constant C is on the other. So as we see in this example, right, oh, not that, didn't mean to do that. On this, you notice that X and Y are on the left side and 12, your constant, is on the right side. So let's look at an example. So this example says, write the standard form of the equation of each line given the slope and the y-intercept. So we have to look at these forms and choose which one of these forms uses or utilizes the slope and the y-intercept. So point slope has a slope but no intercept. Standard form doesn't have slope or intercepts. Yes, we calculate them, but they're not given to us in its form. Slope-intercept form does, so we can take that template, y equals mx plus b, and we can plug that information in. So you see that we have the slope and the y-intercept. So when we are given the equation, we're going to use the template, y equals mx plus b, and then we're going to plug in those values in for m. So we're going to take that -2, we're going to plug it into the m variable, and then we're going to take our y-intercept and we're going to plug it in to the b value. And we're going to rewrite it and see what we get. So if we substitute those values, this template now becomes y equals -2x plus 4. Now the question is, remember, it wants you to write it in standard form. Is this y equals -2x plus 4, is that standard form? What are the criteria? Remember what the criteria are. A must be positive, A, B, and C must be integers, and X and Y are on one side and the constant are on the other. So I can't tell, first I got to make sure that my X and Y are on the same side. So I see that I have my y on the left and my x on the right. So I need to get rid of that -2x. What gets rid of a -2x is a positive 2x. They cancel. We're left with 2x plus y equals 4. Notice I wrote the x first because standard form has the x then the y. So now we have the x and the y on the left side. We have my constant on the right side. Now we have to check, is A positive? So 2 represents the A value, that's positive. Are A, B, and C? So A is 2, B is +1, and C is 4. Are they integers? Yes, they are. So we have our equation in standard form. That's a nice, simple way. We have to use a different form and then manipulate that form to put it in standard form. Let's look at this example. So what are we provided? We're given the slope and the y-intercept. So I'm going to use the slope-intercept template in order to fill in that information. So if I fill it in, I get y equals -1x minus 2. Now, we never say -1x. We always write it as -x, something that's really important. Yes, we plugged it in for m, but whenever we read it, we should never read it as -1x. We should always read it as -x. All right, so we have the equation y equals -x plus 2. So is that in standard form? No, we got to move that x. We got to get rid of the -x. What gets rid of the -x is a positive x. That leaves me with x plus y equals -2. My a is positive. My a, b, and c are integers. Perfect. All right, let's try this one. I'll give you a little time to work on it. Pause the video, and then you try this example. When you're ready, unpause it, and I'll go over the answer. So the first question we asked, what information is provided us? We're provided with the slope and the y-intercept, so we will use slope-intercept form. We'll plug in those values, 1 for m and -3 for b. I wouldn't write it as 1x. I would always write 1x as x minus 3. Now, is it in standard form? No, it's not in standard form. So I need to get rid of the positive x on the right side. So I'm going to subtract x from both sides. And I get -x plus y equals -3. Now, many of you would look at that and say that's in standard form. But remember the criteria. I would not accept this as a final answer. My a is negative, and we can't have a negative a value. So I have to ask myself, what gets rid of a negative a value? How can I manipulate, how can I write an equivalent equation that would make my a positive? So we dealt with fractions and how we got rid of fractions. I think we also talked about how to get rid of negatives. And we would multiply the equation, all the pieces, by -1. If we multiply -1 times -x minus 1 times y equals -1 times -3. So you see that I multiplied each of the pieces, the first, the second term, and the constant over here. And I multiplied everything by -1. So we have -1 times my first term, -1 times my second term, and then -1 times my constant. And if we simplify those, -1 times -x is +x, -1 times y is -y, equals -1 times -3 is +3. Now we notice we just wrote an equivalent equation to my first one. My first one, oh, I didn't mean to do that. -x plus y equals -3. And now the equivalent equation is x minus y equals 3. That would be my answer. A is now positive. A, B, and C are still integers. Let's take a look at this one. This one, again, adds some complexity to it. So we'll do this. We'll go over it together opposed to having you do it first. So we're given the slope and the y-intercept. We're going to use the slope-intercept template. Let's plug in those values. We get y equals -2/3 x plus 5. My x is on the wrong side. I got to get rid of it on the right side. I got to get rid of a -2/3 x. So I'm going to add 2/3 x. Those will cancel. So I'm left with, let's move it over here a little bit, 2/3 x plus y equals 5. Now, again, many students would leave it at that and go, yes, that's standard form. But remember, standard form, my a, b, and c need to be integers, meaning I can't have fractions. So I have this fraction that I have to get rid of. And the fraction, the thing that makes it the fraction is the denominator. Students make a mistake and multiply by the reciprocal. That is not the solution, because that just puts the fraction on the y and the 5. So that's not going to help you. I just need to get rid of this 3 in the denominator. What gets rid of a 3 in the denominator? A 3 in the numerator. Yeah, that's my LCM. So I'm going to multiply 3 times 2/3 x plus 3 times y equals 3 times 5. If I multiply those, 3 in the denominator cancels with 3 in the numerator, leaves me with 2x. 3 times y is 3y, and 3 times 5 is 15. And I was able to get rid of the fraction and, in turn, create an equation in standard form. Good. That's the first big idea. So those problems all dealt with providing information that was the slope and the y-intercept. What's provided in this one? This is a little bit different. Notice what you're given. And I, again, don't like that comma there. That comma's kind of silly. So what are you provided? Well, you're provided a point and you're provided the slope. Is there a template from our 3 templates that we might be able to use to help write an equation with the given information? Well, slope-intercept deals with the slope and the y-intercept, but we're given a point and the slope. Standard form doesn't provide anything, so we're never going to start with standard form. Look at my third one, point-slope form. So, point-slope form template has the ability to plug in the point and a slope. So we're going to use this one. So I'm going to write my template, y minus y sub 1 equals m times the quantity x minus x sub 1. And I'm going to fill in for the point and the slope. So this is my x value, which will go in for x sub 1. Notice I did not highlight the negative because that is not part of what I'm filling in for. And then my 4 is my y sub 1 value. And then my slope is going to be negative 4 in for the m. So I'm going to replace everything that isn't highlighted. So y minus, now I'm going to plug in my y sub 1 value, which is 4, equals m. I'm going to plug in my negative 4 value times the quantity x minus whatever my y sub 1 value is, x sub 1 value is, which is 1. So now we have this equation, and much like when we had slope-intercept form, this is not in standard form. My x and y are not on the same side, and my constant's not on the right. In fact, this equation has parentheses, so I have to address the parentheses first. I have to get rid of those parentheses. The only way that I can get rid of those parentheses in an efficient way is by distributing that negative 4. So it's y minus 4 equals negative 4 times x. I'm distributing that negative 4 to the 2 things inside the parentheses. That leaves me with y minus 4 equals negative 4x plus 4. Negative 4 times x is negative 4x. Negative 4 times negative 1 is positive 4. Now, we've gotten rid of the parentheses. Now I got to move things. So I got to move my x over. So what's going to get rid of a negative 4x is a positive 4x. That leaves me with 4x plus y minus 4 equals 4. And for the first time, we see that, hey, we have 2 constants. I have a constant on the left side and a constant on the right. I got a negative 4 on the left and a positive 4 on the right. They do not cancel each other. You have to mathematically move and get rid of that negative 4. What gets rid of a negative 4? A positive 4. So I have to balance the equation to both sides. These will cancel. That will leave me with 4x plus y equals 8. And that would be my equation in standard form. So lots of stuff there. Lots of new stuff to be dealing with. Let's try another one. Let's see this. So I'm given a point and I'm given the slope. So I'm going to use point-slope form. Y minus y sub 1 equals m times the quantity x minus x sub 1. So I'm going to write y minus, what's my y sub 1 value? Well, it wants me to, here's my y sub 1 value. Here is my y sub 1 variable. Remember that this is written as x sub 1, y sub 1. So it's y minus my y sub 1. So y minus my y sub 1 is going to be negative 4. That can be a little tricky. You have to be careful about that negative. A lot of students will make a mistake there and write y minus 4. That is not correct. So it is y minus the y sub 1 equals m, the slope, which is -4, times the quantity x minus whatever my x sub 1 value is. My x sub 1 value is 1, so it's -1. Now I'm going to simplify a little bit. I'm going to definitely get rid of these double signs. That doesn't work for me. So that becomes y plus 4. And now I'm going to distribute that -4 into the parentheses. So I have -4 times x minus 4 times -1. So we get y plus 4 equals -4x plus 4. Let's move my x from the right side to the left side. I got to get rid of it on the right side. What gets rid of a -4x is a positive 4x. That gives me 4x plus y plus 4 equals 4. Now I got to get rid of the constant on the left side. What gets rid of a positive 4 is a -4. Balance the equation by doing it both sides. That leaves you with 4x plus y equals 0, which is okay. That is, 0 is an integer. So that would be your final answer. All right, this is another tricky one. These next couple of problems are kind of tricky. So we're given a point, we're given the slope. Let's write our template. Y minus y sub 1 equals m times the quantity x minus x sub 1. Y minus, what's my y sub 1 value? 3 equals my slope, which is -1/4, times the quantity x minus my x sub 1 value. My x sub 1 value is -3. So there's a tricky one. Make sure that you are okay with that. That gets simplified to +3. And now let's distribute that -1/4 into the parentheses. Once we distribute, we get rid of the parentheses, and then we can move that x over. We can't move the x until we get rid of the parentheses. So you have y minus 3 equals -1/4 times x minus 1/4 times 3. Y minus 3, -1/4 times x is -1/4 x. -1/4 times 3 is -3/4. That 3 is in the numerator, 4 is in the denominator. And now we have a problem. Well, not a problem. We could move the x over, but I see lots of fractions. And we should know at this point how to get rid of fractions when we have multiple fractions in a problem. We want to multiply it by its LCM. So our denominators are 4, so I'm going to multiply everything times 4. 4 times y plus 4 times -3 equals 4 times -1/4 x plus 4 times -3/4. 4 times y gives me 4y. 4 times -3 is -12 equals 4 times -1/4 x. The 4 in the denominator cancels with the 4 in the numerator. I'm left with -x, not -1x, -x. 4 in the denominator cancels with 4 in the numerator. I'm left with -3. And now this is a nice equation. We like this. This is something that's comfortable. I'm going to add x to both sides. X plus 4y minus 12 equals -3. I'm going to add 12 to both sides. X plus 4y equals 9. Good. And the last problem today is another tricky one. We see that our slope is 0. So we're going to plug it into the template. Y minus 3 equals 0 times the quantity x minus 1. We have to distribute that 0 into the parentheses. So that's 0 times x plus 0 times -1. Y minus 3, 0 times x is 0. 0 times -1 is 0. So that simplifies to y minus 3 equals 0. That is not in standard form. We got to get rid of that constant on the left side. So what gets rid of a negative 3 is a positive 3. Y equals 3. That is considered in standard form. What you really have, if we want to think about it, it really is something like that. Our A value is 0, which takes away our x variable. So we won't see the x variable. This is the only answer you should be writing. This is just think about it. Think about it. Good? All right. Those are some complicated concepts, but I am confident that you can grasp that. Let me know if you have any questions.